Just doing a quick demo of the sustainability on the cloud or green compute that we are working with the FinOps Foundation. So comparing the total CO2 emissions of a car against the total CO2 emission for a cloud workload. So it depends basically on three factors. The energy source of the car, let's say. So this can be a electricity powered car, a fossil fuel powered car, or let's say a futuristic solar powered car. In the same way, the energy source of a data center can be solar electricity, wind electricity, or a fossil or fuel powered data center. The second is the efficiency of the car industry. How efficient have cars become in converting energy into locomotive power? Similarly, how efficient are our data centers deployed in different regions to convert this the power input into useful power? The third is the car used, whether you're using a high powered car or a low powered car. And similarly, comparing it to cloud SKUs used, whether you are using a 16x machine or a 2x machine. And these three factors combined together, we can come with the total CO2 emission of a cloud workload or a total CO2 emission of a car. With this, I'll be using a quick demo. So first, we'll be looking into the energy source of the data center. For this, what I used was the electricity maps. So the electricity maps is an open source project that tells us what is the carbon intensity of a particular region. In this case, we can see that the carbon intensity of North Sweden is 14 gram per kilowatt hour, whereas if we go to a region like Poland, it is around 500 gram per kilowatt hour. So some regions are intensely more carbon efficient than the others. So what I did was map this data to the actual maps. So what do I mean by that is, so these are the different electricity zone IDs and electricity map. And how does this region corresponds to a AWS region or Azure region or a GCP region? So here we can see that the zone ID is, let's say, Austria, and Azure has a region in Austria. Similarly, we can see that there's a zone ID called in Belgium, and GCP has a region. So this mapping was done very manually, and the primary assumption there is that a particular data center does not get electricity in from two or more electricity zones. And secondly, how much is the data center itself doing? Like, do they have renewable energy? So these are the two assumptions. So collected data from the electricity map and mapped it on a dashboard or a time series database such that we have data for the past 30 days. How is the electricity trend varying? So in the top, we can see for carbon intensity for France, and this over the last 30 days, how much has the intensity been varying for the time of the day, and what is the fossil fuel percentage that has been used. For a region like Ireland, is something that is the pattern that is visible is the fossil fuel percentage can go very low and it can go very high depending on different times of the day. So two conclusions here. This can help pick better regions and this can help pick better times. What do I mean by that? There are some regions that are intrinsically better to launch. And secondly, there are some times that are intrinsically better to launch. My assumption was validated by this Google mm, document or white paper where they said that our data centers now work harder when the sun shines and the wind blows. And as we can see in this image, so here is a conventional cloud workload. And now they're aligning compute workload with low carbon energy. So a traditional workload is distributed throughout the day. And when the wind blows high or the sun shines, they are aligning to run during that time. So had this data in place, like the time series data, and we had this map to electricity map. So the first part of the questions is answered with this. Now, the second part of the question is efficiency of the data center. So for this data, I went to the website of Azure or the cloud providers and figured out what is the PUE or the power usage effectiveness of a data center. So this, like this, a traditional document looks like. So in the region of Singapore, the power usage effectiveness is 1.364, and the water usage effectiveness is also provided. So mm, map this data on separate sheets, like these are the different Azure regions, and this is their power usage effectiveness. So the second part of the puzzle, the efficiency of the data center, was answered like this. Coming to the third part of the puzzle, which is the cloud resource type used. So for this, use the TEEDS data, the data that is open source, where they give, like, for a particular instance type, what is the what usage, and at of the CPU usage, RAM usage, and the GPU, and they combine to form the total instance usage. So use this data to shortlist the most common instance types that I've seen being used on the cloud, and try to figure out, like, let's say we are launching a instance in Sweden versus Poland. So what is the carbon impact of this particular instance can be? Took up substantially large data to start with, such that I wanted to see the impact. So it's a X1E.4x large. And on doing the calculations, it was like evident that we can save 2 million grams of carbon just by launching the region in Sweden rather than in Poland, considering we don't have latency limits here. So, but what does 2 million grams of carbon mean? So for that, I used the EPA website and was able to figure out that 2 million grams of carbon is equivalent to 5,000 miles of car driven, or 250,000 smartphones charged, or 33 trees planted in a year. So this was the POC that was done. And finally, what I did was move this data to Athena, where I did a comparison that is real lifetime, live on the live data center usage of all the instance type across all the different regions. For example, here, what we can see that for a T3.large, there are 17 regions that it can be launched. There might be more. For the beginning POC, there are only 16, 17 regions in this POC. And what is the idle kilowatt hour usage of at different regions? So in EU North, it can be 1,000. It will be 1,000 kilowatt hour, whereas in AP South one, it can be 34,000. So there can be a 34x difference if instance is launched in the right region. So this was a quick demo of the work that I had been doing on the sustainability space. Hope you enjoyed it and open to feedback.